Question 1. The curve y equals to kx squared minus 4x plus k plus 3 touches the x-axis at the point P. We have y equal to kx squared minus 4x plus k plus 3. A is equal to k, B is equal to negative 4, and C is equal to k plus 3. Touches the x-axis indicates that it has two equal roots. Therefore, b squared minus 4ac is equal to 0. A. Find the possible values of k. Possible values, we might get more than one answer. This part is actually from the previous topic, roots of quadratic equation. To solve this question, we are going to substitute the value of a, b, and c into the discriminant. b squared minus 4ac is equal to 0. Negative 4 squared minus 4, k plus 3 is equal to 0. We expand the equation. Negative 4 squared, we get 16, minus 4k squared. Negative and positive, we get a negative. 12k is equal to 0. This is a quadratic equation, but before we solve the quadratic equation, we simplify it first so that it is easier to factorize later. We divide the equation by negative 4 and rearrange it at the same time. We get k squared plus 3k minus 4 is equal to 0. We open two brackets. K squared is k and k. 4 is either 1 and 4 or 2 and 2. To get positive 3k, we need this combination, 1 and 4. To obtain plus 3k, we plus 4k minus 1k and let it be 0. Hence, k minus 1 is equal to 0, k is equal to 1, or k plus 4 is equal to 0, k is equal to negative 4. B. Given y equals to kx squared minus 4x plus k plus 3 can be expressed in the form y equal to k bracket x plus p squared plus q. Find the values of p and of q for each value of k obtained from A. Hence, state the maximum or minimum point for each value of k. There are two things that we need to do. The first one is to find the value of p and q for each value of k that we obtain from A. And then we need to state the maximum or minimum point for that particular k value. We will do this one by one. When k equals to 1, our equation is y equals to x squared minus 4x plus 1 plus 3, which is x squared minus 4x plus 4. To express the equation in vertex form, we need to perform completing the square. Before we do so, we need to make sure the A value for this equation is equal to 1. For this case, our A is equal to 1, hence we can continue from here. We put the x here and the square here, minus b over 2. Then we need to minus negative 4 over 2 square, and also plus 4. Then we simplify the equation, x minus 2 square minus negative 2 square plus 4, which is x minus 2 square minus 4 plus 4 equal to x minus 2 square. Compare the equation we get with the given equation. When k equals to 1, p equals to negative 2, q equals to 0. Q equals to 0 indicates that our maximum or minimum value is equal to 0. And it actually makes sense because the question stated the curve touches the x-axis. For this case, k equal to 1, meaning A is greater than 0. It is a smiling curve and it will be minimum point. The minimum point is 2, 0. When k is equal to negative 4, our y will be negative 4x squared minus 4x plus negative 4 plus 3. Simplify the equation. Negative 4x squared minus 4x minus 4 plus 3, and hence negative 4x squared minus 4x minus 1. Similar to what we did for k equals to 1, we need to perform completing the square. For this case, we need to factorize the negative 4 outside the bracket. Negative 4 x squared plus x plus 1 over 4 equals to negative 4. We will do the completing the square inside this bracket. X here, square here, plus b over 2 minus 1 over 2 square plus 1 over 4. We simplify the equation. Negative 4 x plus 1 over 2 square minus 1 over 4 plus 1 over 4, which is negative 4 x plus 1 over 2 square minus 1 over 4 plus 1 over 4, we will get a 0. So it will be negative 4 x plus 1 over 2 square. Compare this with the given equation. When k equals to negative 4, p is equal to 1 over 2 and q is 0. K equals to negative 4, meaning our a is less than 0, hence it is a crying curve, so we will get a maximum point. Our maximum point is negative 1 over 2, 0. Question 2. In figure above, 2, negative 1 is a maximum point of the graph of y is equal to p bracket x plus h square plus k. The informations we have are y is equal to p x plus h square plus k. Maximum point is 2, negative 1. From the diagram, we also get the y-intercept. Y-intercept, c is equal to negative 9, and hence the coordinate for the y-intercept is 0, negative 9. A. Find the value of p, of h, and of k. Since we are given the maximum point, we can obtain the values of h and k easily. 2 is our symmetrical line. And negative 1 is our maximum value. For symmetrical line, x plus h is equal to 0, x is equal to negative h. In this case, negative h is equal to 2, therefore h is equal to negative 2. The maximum value is k, and in this case, it is negative 1. To find the value of p, we need to substitute the values of h, k, and the coordinate 0, negative 9 into the equation. Negative 9 is equal to p bracket 0 minus 2 square minus 1. We simplify the equation, we get p negative 2 square minus 1, which is equal to 4p minus 1. Further simplify the equation, 4p is equal to negative 9 plus 1, which is negative 8. P is equal to negative 8 divided by 4, negative 2. Hence, the complete equation is y is equal to negative 2 x minus 2 square minus 1. B. Find a new equation of the graph when the graph shown is reflected on the x-axis. When the graph is reflected on the x-axis, it will look like this. The original y-intercept is negative 9. Since it is reflected on the x-axis, now it becomes 9. Instead of maximum value, the new graph will have a minimum value. The coordinate is 2, 1. Let's gather all the information. Y-intercept is equal to 9. Minimum point is 2, 1. We can compare the information we have with the original equation. This part is the symmetrical line. From the graph that we sketched just now, this part is unchanged. Negative 1 is the maximum value, but now it becomes the minimum value 1. As for the A value, the shapes of the curve is unchanged, but it has become a smiling curve. Hence, our A value will become positive 2. Therefore, the new equation is y is equal to 2 x minus 2 square plus 1.